Look how we stats, guys.
Final MCDF. 12.
Not fun. It's fun when there's no context. Let's see here. Where are we at? Here? No. Yes?
Yes.
No.
Other one.
Yes?
Yes.
No. No. Okay, so here we go. All right, so we're okay here? We'll do the other one too, okay? So let me clear the ink here. Let's do cosine. Now again, if you want to work it in radians, go for it. Do it in the radians.
Yes, try to do it.
My denominators are 4, which means I'm working with what type of angles? 45s, right?
Yeah.
So I'm going to kind of do, I should break. Here.
Because if yeah,
So I need to do 9 of them, right? So I've got, and backwards. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the one I want. Okay, now if you want to convert that into degrees, more power to you. That's going to put me at pi fourths, which means it's a 45-degree angle, right? What?
that's just 8.
So it's 1
Oh
again?
no, it's going backwards.
I went backwards.
Oh, wait, never mind.
So from here I went 1, 2, 3, 4, 5, 6, 7, 8, 9.
I see. I was confused.
Okay. So now it's a 45-degree angle, which means this is a positive one. This should be a negative one, and this would be radical 2. The hypotenuse will always be positive. Okay, because it's just a distance. So now they want the cosine, which means adjacent over hypotenuse. That's 1 over radical 2. Math lab might let you get away with that because they really stopped rationalizing from what I hear in college. But if it does want you to rationalize, then that becomes radical 2 over 2, and you are done. And the cosine is positive, so it should be positive, right?
You're matching your fan.
Wait, couldn't you?
I was trying to dress like Superman.
You're matching your fan.
Yeah, you wait.
So if you have the unit circle, you could use the unit circle.
Yeah, if you have it printed out, if you have the unit circle printed out, you can use that. But you really want to get into the habit of practicing coming up with them because, like, when you take stuff like ACT or whatever it is, they won't give you that, and you really need to know those. Or your placement exams, and it's just nice that you know where it comes from. You will feel a lot more comfortable.
Comfortable. You people say that it depends how you say it. So you know how you
Well, you don't say comfortable. You're supposed to say comfortable. Yes. Those of you that are taking calculus, and maybe you can. Did you take calc with the JV program? Okay. Well, when you do take calculus, you're going to want to be very comfortable with your trig, because that's where a lot of people are going to struggle, because they don't remember the inverses and all that good stuff. And yeah, I'll tell you, you'll be hurting.
Wait, what's the opposite?
What's the opposite of what? Opposite of the inverse of cosine? Secant. Secant. Alright? What is this? That's just the same thing again with all the periods in them. And just means how many periods of it you're going through, right? You're multiplying that by 4, 5, 6, depends how many periods. Are we okay with that?
Yes.
We don't need to say much there. Okay. Now, you can find some of these that are not as nice. Now, right now, we got some nice ones just because I felt like it. And it was on the presentation. But you can do this with a not nice one. So, like, if you do end up with an 83 degrees or whatever, and you need to find sine of that, you're going to grab your calculator. So, let's do sine pi fourths. Right here, there's a button that says sine. Sine. And I want to take pi. Please make sure you use pi. If pi is a second on the caret, dividing it by 4. That's called the caret. And there you are. No, because I'm in radians. It's pi fourth radians, right? Wait a minute, it's not the same number?
No, it
Yeah.
is.
Yeah, remember, you see pi, you're probably working with radians, right? Yeah, you should be. Now, if it said degrees, then that would be different.
How would you do?
Here, watch. So
Yeah.
everyone knows pi force is 45 degrees, right?
Yeah.
So if I did sine 45, it's going to say something different. See that? Because I'm not in degree mode.
Yeah.
So I've thrown in a radian. Make sure you're in radian mode. But if I did go over to mode and switch from radians to degrees,
You get the same thing.
I would get the same thing, right?
Yeah, I did.
So watch here.
I didn't know that's what you had.
Second entry. Oops, sorry, that's not what I wanted. Second entry. So now I'm in degree mode. I'm doing sine 45. It knows that it's 45 degrees.
When you're in reading, you also put like the degree sign
Too much digging. But there's a degree symbol out there.
It's an app.
Oh,
No, it's
it's
just second apps.
yeah, math.
Second apps.
Second apps.
Oh yeah, angle. There you go. Thanks. And if you need to do stuff, there's your degrees, minutes, and then there's seconds. Yeah, seconds.
And then minutes.
It's two of these.
And then minutes, you gotta put second. If you put in two
Seconds, it's two of these.
it doesn't work.
It doesn't work? So is that what the little R is going to be, or what?
No, you do the thing. No, you do the second plus. Yeah, it's all the way down. No, alpha
You have to do alpha plus.
Alpha plus?
Oh yeah, because it's right here. There's two of them right there. An alpha plus.
Alpha plus.
Alpha and then plus.
Oh, there it is. Yeah. Thanks. I see it. I see it. It's bleh. It's the alpha character on the plus symbol by memory. Thanks. Anyways, moving on. Whoever said it, thank you. I think I have another slide left. Oh,
We didn't do
cosecant.
Hey, how you do that?
If you have an inspired, it will have cosecant. If you have an inspired, you get sine, cosine, tangent, secant, cosecant, cotangent. Yay, inspired. Everybody else, we not so lucky. No, Desmos, I'll show you what to do.
Just 1 over.
Isn't it
If you
just
remember from the formulas I gave you,
1 over.
where'd they go? Here they are.
1 over.
Cosecant is simply 1 over sine,
1 over. Whatever.
right?
Yeah.
So if we want to do, where'd it go?
All the way down at the bottom, it was like 21.
So if we want to do
21.
this, we're going to go, where'd it go? Here you are. We're going to go 1 divided by the sine of, what was it, 1.5?
Yeah.
To close that. So it's going to have to look like this. Ah. Ah, yeah. And there you are. Okay? So you have to do the 1 over business for those formulas.
That's
Okay?
not too bad. That's great.
That's not bad. Okie dokie artichoke.
Okie-dokie. J.
Alright. That is it.
I know how you feel.
So let's do questions from. Ah,
The others make sense now.
Mine's 6 and 7.
She's not using mine. She's just using his other reference.
I think I'm gonna record my password. Don't remember my password.
It's a list
It's dot 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 dot.
How many dots?
Right.
Biology was
My password is APP, right, Lissa?
I remember elementary education.
Is it like one of the high?
What am I doing?
Yeah, we love him too. I didn't have to cheat in Wisconsin anyway.
All right, what do we have? This? Which one?
They said 6 and 7.
5 and 6, 6 and 7,
No, just 5 and 6.
7, 8, 9.
10.
All right, so the angle T is an acute angle, and sine T is given. So that means that we're in quadrant 1, correct? The acute obtuse also helps, because if they said it was an obtuse angle, that means my angle would be like this, wouldn't it? And this would be the one I'm after, because this is the angle that creates the hypotenuse. But they said the angle was acute. Thanks for not working. So that means that I'm after the one that's in quadrant 1. And the sine is 2/3. Okay, so they want me to find cosine. I don't know what angle it is. So what I'm going to have to do is use my Pythagorean theorem to figure out the hypotenuse here. Oh, wait a minute, that's not right. This should be a 3 here. It's opposite over hypotenuse, correct? So I'm going to have to do 2 squared plus b squared equals 3 squared. That's 4 plus b squared is 9. Take away 4 to both sides. So this ends up being radical 5, right? We're good? Greg? We end up getting radical 5. So this is radical 5. They want us to do cosine. So it's going to be radical 5 over 3. It's the adjacent over the hypotenuse. So let's go divide. And then I want radical 5. And then the denominator,
You gotta go over and then down.
I want a 3. And there it is.
Okay, now it's easy.
Okay?
Number 6. So that's like with you like drawing it out. That would be that is that considered going
To draw what out?
to draw like the
I always do. Pictures always make more sense. It keeps things in perspective. It's perspective, right? It's perspective.
That's nice. I like that word. It's perspective.
It's perspective.
Nice. It's a new word.
I don't speak English. I'm speaking in the math. All right. So again, this probably has like all kinds of parts to it, doesn't it? No. Find the exact value of the given trig function. Don't use a calculator. What?
Yeah, you just did that.
Sure is, huh? Sure is. So, let's see here. It was the last one we did too, wasn't it?
Yeah.
Let's see here. So, that denominator 4 tells me that I'm working with 45s. So I want to do 9. I think it ended up here, didn't it?
Yeah, but that was a
That's the
negative.
negative.
But it's a positive.
Oh, this one's positive, so it's not going to end up there.
So it's gonna end up in the one above.
So let's do the positive one then. And I'll just do it again just for doing its sake. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the one I'm after.
Yep.
And it's a 45 degree. We just said that a minute ago. So therefore 1, 1, radical 2. I want secant, which is the reciprocal of cosine.
And cosine.
So cosine would be 1 over radical 2, right?
Yeah.
But I want the flipped version of that. So I'm just going to get radical 2. So that's just going to be radical 2. Any questions, please ask them. I feel like I'm going fast here.
No.
You do it so easy. Like whenever. Go to
Well, I mean,
question
he's
help
a
and see how they
No.
do it.
I don't go to question help. I like to keep my sanity.
No, but like.
Look, I'm not going to show you the hardest way to do things. I'm going to show you the best way that I know, the easiest way always. With the stuff that makes sense to moi. All right, we're good?
Wait, what was the one now?
Because I'm pretty. Did question help make you convert it to a degree? Graph that.
No, it makes you subtract 2 pi.
This is
Something.
I don't know.
It was difficult. That's all you gotta say.
Did what I do make sense?
Yes.
So you did all that with what I did. See how I went around?
Oh yeah.
I just counted. I was subtracting what I don't need. So,
Okay, so the one over square
It'll be next.
where's that from?
Wow.
say that one more time.
The one over the square root of 2 that equals 6.
This is just a regular 45, 45, 90. Right? So 1, 1, radical 2. And if it was a 30, 60, 90, it'd be 1, 2, radical 3. I'll do this one again. Did someone say do this one again?
Yes.
Number 7, 8, 9.
That one.
Yeah, that tripped me out.
And it always turned out to be like one answer. It was like.
It was
right,
very.
two over one over and over and over.
Find.
Isn't it very
Whoa, what the what? That's cool. So, let's do this real quick. How about we do this? This is going to be, So I know sine has how many periods? It's a 2 pi period, right?
Yeah.
So I'm going to figure out how many times it's gone around the circle. And I'm just going to get rid of those things, okay? So I've got 1,000 periods in there. 1,000, if I turn it on, it works better, doesn't it? 1,000. And I'm going to divide by 4. No, I don't want to divide by 4. I want to divide by... Yeah, I want to divide by 2.
No, you want to divide it by
Because
2,
remember, it's
the
2
period
pi.
is 2
The
pi.
period of sine is 2 pi.
So that'll show you how many times it went around the circle.
So it's gone around 500 times. So if it's gone around 500 times, I don't really care. I don't really care. Because all it's doing is just going around itself,
It
right?
ignores it all.
And then I'm going to look for this. Hopefully, let's see if my theory is correct. So I'm here again, aren't I? And this is again another 45.
Yeah.
So I've got 1, -1, radical 2. So the sign there is, let's see here, opposite over hypotenuse, so -1. So this is going to end up, oh, you know what? I'm going to try that. I'm going to try to not rationalizing. Is that cool with you guys?
Yeah, but
That's what they do. That's what it is. Like,
-1 over radical 2.
yeah.
I went to
It works. Just-
I went to question help. Like, I shouldn't.
Okay?
Nope.
Well, let me tell you, I'll re-explain. All this number is telling me
Is how many
is how many times I went around the circle. That make sense?
If it's divisible by 2, it's
No, I didn't even have to do any of that. I didn't even have to do that at
The
all.
only thing
All
that
this is
matters
telling
the
me,
negative sign.
now if this was off, maybe, I don't know, like a 1 maybe, it'd be kind of different, but
No, it would all.
it doesn't even matter, right? Because it's just another revolution.
Um,
So all that this said is, you know what? Here's the angle I'm at, okay? Let me clean this up a little bit. I'm at this angle. I'll draw it again. This is -pi4. And this part of it says I went around my circle 1,000 times. And I stopped there again. So I'm not going to sit there and do that. I don't care that you have that many revolutions. All I'm after is that angle. It's going to be coterminal. So I'm just going to find the sign of that. Remember we said that? We said that this number is simply the number of revs I went over. Okay? And this is technically the 2 pi n version of it. So that's why I was dividing by 2 to see how many revs I had in there. But that's even irrelevant. That's also irrelevant. I don't even need any of that to find the value of the trig function. Now, if they said, how many revolutions did this have, then that would matter. Right. Then I'd be after this number, and this number would be irrelevant. Right? So,
if it was positive, it would be a different answer, right?
yeah, because you'd probably end up at the top. You have to revolve. All right. Questions? Does everyone understand why the 1,000 pi was irrelevant?
Now I understand.
All right, cool.
how did you, okay, so after you got -pi4, how did we get -4? Oh, because it was a 45.
Right, because this 4 tells me that I'm working with 45-degree angles.
Okay, see, that's what question help didn't tell me. It was just like, oh, okay,
Question,
how
yeah.
did we simplify it to this?
I want you to understand what's going on. Yeah, that's the difference there, okay? I can change this to the next one now? Any other burning questions from this? All right, let's go.
Oh, that one was easy.
Oh, what that? So much reading. Use the unit circle to find the value of cosine 3 pi halves. Hey guys, what does the half tell me I'm working with?
190.
90-degree angles. And periodic properties of trigonometric functions to find the cosine of 7 pi halves. So here, check it out. This is 7 pi halves, right? So here's 1, 2, 3, 4, 5, 6, 7, right? And then I've got, I don't know if you can see that, but that's 0, -1. And I want the cosine value, which is the x value. So that's just 0. Okay? But that why it was critical to understand where that unit circle came from. If you never understood the unit circle, then all of it was probably like, ah, oh my God, what is that?
I just didn't really know how to apply it.
Now you do?
Yeah.
Yes.
Dude, I've never understood more math than I do right now.
That's gonna be the same thing.
Anything?
It's the same
Oh, there's more.
It's the same thing.
But the first part was asking for 3.
3 over 2, and then the second one was down here for 7 pi over 2.
Huh?
It's just 0 again. Just put in 0 because that's what it is again.
It's just a revolution.
Yeah, they're called terminal.
Probably not, but close.
Oh, wait, you could have just.
Oh yeah, okay. Is that what it was making a point of?
Yeah.
Okay, so check this one out. This one is 40 degrees, right?
Yeah.
Sorry, not 40. It's a denominator of 4, therefore I'm working with 45 degree angles. So I want one of them, don't I?
Yeah.
So that's here, and I want the y value,
Yeah.
which is radical 2 over 2. It's radical 2 over 2, so fraction, radical, and then 2, and on the bottom, my 2. And there it is. Okay? And then the other one, is it going to do a coterminal again?
Yeah, I want 17.
Yeah, so if you for some reason don't know it's coterminal, just count them up. I've got 1, 2, 3, 4. Did I miss one? I feel like I missed one.
No, because you're at 4.
Well, it should be 8. 8, 16, and one more makes 17.
Yeah.
And then you're back in the same spot, so
It's just
it's the
that
same
again.
thing. Okay? Anybody need 10?
No.
Okay. Yeah, trig is fun. Trig is, I like it a lot. I like it a lot.
10 was just 1. Because you multiplied y over 1 over y.
Yes, just move on.
Yeah.
Oh yeah, that one wasn't very hard.
Oh, for those of you that don't see it,
It's,
this is sine 67 degrees multiplied by 1 over the sine of 67 degrees, right? That's cosecant.
Yeah.
So this cross cancels.
1.
So you get 1 over 1, which is just 1.
What is it?
Right, it's the reciprocal of it. It's the multiplicative inverse, if you want to get technical about it. Alright, we're good?
Yeah.
Alright, I'm going to turn off the recording.